Imagine a world where organs are printed on demand, homes are built in days, and astronauts on Mars create their own tools, all thanks to 3D printing. This is not science fiction. 3D printing, or additive manufacturing, is revolutionizing how we make things. Instead of carving objects from blocks, we now build them layer by layer from digital blueprints, reducing waste and unlocking new possibilities. From jet engines to custom shoes, 3D printing is localizing, personalizing, and streamlining production. The power to create is shifting to designers, engineers, doctors, and you. Let's explore how this technology is reshaping industries, economies, and our future. 3D printing works like a regular printer, but instead of ink on paper, it stacks layers to form solid objects. It starts with a digital design, a CAD file, sliced into thin layers by software. The printer then deposits or solidifies material, building the object from the ground up. Unlike traditional manufacturing, complexity doesn't add cost or time. Materials range from plastics and metals to ceramics and even living cells. This flexibility means 3D printing can tackle challenges across industries. Turning digital ideas into real objects is now just a click away. 3D printing has exploded recently due to faster computers, cheaper printers, and demand for custom, sustainable products. Early machines were huge and expensive, but now anyone can own a printer. Expired patents and open-source innovation have slashed costs. Today's consumers want personalized goods, and industries need greener, more resilient supply chains. 3D printing answers both calls, cutting waste, reducing transport, and enabling local production. Recent global disruptions have only accelerated this shift. The technology is ready and the world needs its solutions now. Manufacturing is a $13 trillion industry, employing 350 million people worldwide. Mass production has made goods affordable, but relies on fragile global supply chains and creates massive waste. Traditional methods often discard most raw material, up to 90% in some cases. Long-distance shipping adds to pollution and vulnerability. Recent crises have exposed these weaknesses. 3D printing offers a more efficient, local, and sustainable alternative. The need for a new manufacturing paradigm has never been clearer. The 3D printing industry is worth $20 billion, tiny compared to traditional manufacturing, but growing fast. Its value doubles every few years, driven by breakthroughs in speed, materials, and software. Aerospace, medicine, and automotive sectors are leading the way, inspiring others to follow. Analysts predict the market will top $100 billion within a decade. 3D printing flips the economics, making one unique item costs the same as making thousands. This agility and customization challenge the old mass production model. It's not just a tool, it's a new way to create. Traditional manufacturing employs millions. 3D printing, about 300,000 highly skilled workers. The shift is from manual labor to digital design, engineering, and machine operation. As 3D printing spreads, demand grows for creative, technical, and problem-solving skills. Jobs will change, some lost, many new ones created in digital craftsmanship and sustainable design. Manufacturing could return to regions once lost to cheaper labor as innovation trumps cost. The challenge: retrain and educate workers for this new era. The future of work is creative, digital, and driven by 3D printing. The core economic argument for 3D printing is profoundly compelling. It rewrites the rules of production, moving away from the rigid model of the past towards a flexible, localized, and on-demand future. Additive manufacturing inverts economic logic. Complexity has little impact on cost, and there's no need for product-specific tooling. This allows for rapid prototyping, test and refine a new product in hours, accelerating innovation and reducing costs. With 3D printing, companies can simply print parts on demand from a digital file. Ultimately, the economic rationale is about creating a more resilient, efficient, and responsive manufacturing ecosystem. Three-dimensional printing dramatically reduces industrial waste. For centuries, manufacturing has been subtractive. We cut, drill, and carve away material we don't need. Additive manufacturing turns this paradigm on its head. Instead of removing material, it adds it, one layer at a time. The amount of raw material consumed is almost identical to the amount in the finished product. This shift represents one of the greatest leaps towards sustainable manufacturing, promising to conserve resources. Companies can slash their production costs, making them more competitive. The environmental impact is transformative. Three-dimensional printing significantly lightens humanity's industrial footprint. Additive manufacturing shifts away from centralized production. Three-dimensional printing dismantles geographic necessity, bringing the factory directly to the community. This decentralization can revitalize local economies, empowering small businesses to become manufacturers. This democratization of production can foster local innovation, creating bespoke products and keeping wealth circulating locally. This shift creates opportunities for high-skilled jobs within communities. It fosters economic resilience and self-sufficiency. Global knowledge combined with local production builds a more prosperous future. Traditional manufacturing relies on intricate globe-spanning supply chains, but they are vulnerable and costly. Three-dimensional printing offers a solution by moving manufacturing closer to consumption. Instead of shipping goods, we can transmit digital files instantly. This reduces carbon footprint and creates economic resilience. A decentralized network provides a robust alternative to supply chain disruptions. Digital libraries replace physical inventory, freeing capital and reducing waste. Three-dimensional printing enables a circular economy, a model that involves sharing, reusing, repairing, refurbishing, and recycling materials. Materials are kept within the economy to be used again, creating further value. Additive manufacturing champions the right to repair. Replacement parts can be easily and cheaply produced, extending the life of products. Three-dimensional printing is revolutionizing the use of recycled materials like plastics and metals. Plastic waste can be transformed into raw material for printing new consumer goods. By creating a direct, high-value use for recycled materials, three-dimensional printing provides an economic incentive to improve recycling. The technology allows for the design of products that are easier to recycle because parts can be made from a single material. This vision of a circular economy is being made a practical reality by three-dimensional printing. The economic model of the 20th century was built on mass production, making millions of identical items to drive down costs. This one-size-fits-all approach was efficient, but it often failed to meet the specific and diverse needs of individuals. Three-dimensional printing fundamentally overturns this model, ushering in the era of mass customization. Because the technology does not require any physical molds or tooling, the cost of producing one unique item is the same as producing the first of 1,000 identical ones. This economic reality unlocks the ability to tailor products to the precise specifications of each individual customer, without the prohibitive costs traditionally associated with bespoke manufacturing. This capability has transformative implications across countless industries. In healthcare, it means prosthetics that are perfectly matched to a patient's anatomy, surgical guides printed from a patient's own scan, and even personalized medicines with dosages tailored to an individual's specific metabolic needs. In the consumer goods sector, it means footwear designed for your unique gait, eyewear that fits your facial structure perfectly, and products that you can co-design yourself, expressing your own creativity and style. This level of personalization creates products with higher value, greater utility, and a stronger emotional connection for the user. The on-demand nature of this production model also yields significant economic and environmental benefits by eliminating overproduction. In the traditional retail model, companies must forecast demand, often inaccurately, leading them to produce vast quantities of goods that may never be sold. This results in clearance sales, overflowing outlets, and ultimately, millions of tons of unsold products being sent to landfill or incinerated each year, a colossal waste of resources, energy, and capital. With three-dimensional printing, products are only made once an order has been placed, ensuring that every single item created has a guaranteed home. This shift from speculative production to on-demand manufacturing is a powerful force for sustainability. It ensures that precious raw materials are not wasted on unwanted goods and eliminates the environmental impact of disposing of them. For businesses, it removes the financial risk of holding inventory and the costly problem of managing returned goods. If a customized product is not quite right, the digital file can be easily adjusted and a replacement printed, with the original item often being recycled directly into new material. This economy of one is therefore not just about personalization. It is about creating a more intelligent, responsive, and profoundly less wasteful system of production. Imagine a world where your shoes fit perfectly from the very first step, and your clothes are not just off the rack, but designed precisely for your body and your taste. Thanks to the marriage of 3D design and 3D printing, this vision is rapidly becoming reality. In the evolving landscape of fashion, these technologies are empowering designers and consumers alike. Custom-fit trainers, individually tailored dresses and accessories with intricate, never-before-seen patterns are now possible, each piece as unique as the person who wears it. No longer constrained by mass production, creativity flourishes, giving rise to styles that truly reflect personal identity. But the transformation goes far deeper than aesthetics. Traditional fashion manufacturing is notorious for its excess, offcuts, surplus stock, and unsold garments piling up in landfills. 3D printing flips this script. By producing items on demand and to exact specifications, it significantly reduces material waste. Every thread, every filament, every drop of dye is used with purpose, supporting a move towards waste-free circular fashion. This shift isn't just about looking good, it's about doing good. Sustainable materials, efficient processes, and localized production chains lower the industry's environmental footprint. The result? A fashion future that's not only more creative and personal, but also kinder to our planet. As we continue to weave technology into the fabric of our lives, 3D printing is ensuring that the next big trend is sustainability itself. Fashion is being redefined. One layer, one design, one perfectly fitting piece at a time. Section 2: Building the Future, Construction and Sustainable Housing. The construction industry is on the verge of a radical transformation. Three-dimensional printing is poised to change all of that. Imagine erecting the walls of a house in just a matter of days. It's actually happening right now in projects across the world. This technology offers a powerful solution to the global housing crisis, making housing more affordable and accessible. Additive manufacturing can create complex curves and organic shapes with no additional difficulty or cost. Crucially, this method is a gateway to more sustainable building practices, laying the foundations for the sustainable cities of tomorrow. Section 3: Reaching for the skies, aerospace and defense. In the demanding worlds of aerospace and defense, every gram matters. Lighter aircraft are more fuel efficient and can carry heavier payloads. Three-dimensional printing has shattered traditional constraints, enabling the creation of strong and lightweight components. Major aerospace companies are now 3D printing thousands of parts, from brackets to turbine blades. This leads to safer, more reliable aircraft that consume less fuel and reduce environmental impact. In the defense sector, field deployable printers can manufacture spare parts on demand, revolutionizing military readiness. Three-dimensional printing is also indispensable for space exploration, enabling astronauts to print tools and habitats using local materials. It's helping us reach for the skies. Section 4: The Automotive Evolution, Driving Towards Digital Manufacturing. The automotive industry is undergoing a profound evolution, and three-dimensional printing is a key catalyst. Additive manufacturing provides the agility the industry needs, starting with design. Automakers can now three-dimensionally print full-scale concept models and functional prototypes in days. Engineers use three-dimensional printing to create custom tools for the assembly line itself. We are seeing three-dimensional printing move into the final vehicles themselves. More importantly, it is revolutionizing the market for spare parts. Car companies can maintain a digital catalog of parts and print them on demand. This could lead to vehicles that are not only cheaper and faster to produce, but also safer and more fuel efficient, driving the automotive industry towards a more agile, customized, and digitally driven future. Three-dimensional printing in the culinary world is a rapidly growing field. Food printing is used by chefs to create intricate food designs. It also offers a solution for personalized nutrition, tailoring meals to individual needs. This technology promotes sustainability and reduces food waste by utilizing discarded ingredients. The vision is a smart kitchen where a food printer prepares balanced meals based on your needs. It empowers individuals to take control of their health in a personalized way. Food printing gives us a glimpse of a future where food is creative, sustainable, and designed for our well-being. When 3D printing began, it was largely associated with plastic. Today, the palette of printable materials is diverse and growing. We can now print with industrial-grade metals, opening a new frontier for manufacturing, creating strong parts for aerospace, automotive, and medical implants. The innovation doesn't stop with metals. We're seeing advanced ceramics, transparent glass, and even natural materials join the revolution. Perhaps most astonishingly, we are printing with food. This versatility is key to the technology's widespread adoption. The potential applications will only continue to multiply. At the very heart of invention lies the prototype. It turns a concept into a tangible object. Three-dimensional printing has shattered the bottleneck of traditional prototyping, unleashing innovation. Designers can now go from digital design to physical prototype in hours, revolutionizing development. This creates a fast-paced cycle of designing, printing, and testing. This speed and affordability encourages a culture of fearless innovation. This ability to fail fast, learn quickly, and iterate relentlessly is the engine of modern innovation. It leads to genuinely better products. The power of the prototype, now unlocked for all, is a catalyst for a more innovative world. In our quest for a more sustainable future, one of the greatest challenges is our linear take, make, dispose economy, which generates mountains of waste and depletes our planet's finite resources. Three-dimensional printing holds a powerful key to unlocking a more circular economy, where materials are kept in use for as long as possible, recycled, and regenerated into new products. A new wave of innovation is focused on creating high-performance filaments and powders derived directly from recycled waste, turning a problem into a valuable resource. Imagine a world where the plastic bottles polluting our oceans are collected, processed, and transformed into the raw material for printing everything from stylish furniture to durable footwear. This is not a distant fantasy. It is already happening. Companies are developing entire supply chains dedicated to converting post-consumer waste into high-quality three-dimensional printing filaments. It is a tangible way of cleaning our planet while creating useful, desirable products. As powerful as three-dimensional printing is on its own, its true transformative potential is being unlocked when it is combined with another revolutionary technology, artificial intelligence. This digital synergy is creating a powerful partnership that elevates additive manufacturing from a simple production tool into an intelligent, self-optimizing system. AI is being integrated into every stage of the printing process, from the initial design of an object to the final quality control, pushing the boundaries of what is possible in terms of complexity, efficiency, and reliability, creating a virtuous cycle of constant improvement. One of the most exciting applications of this partnership is in generative design. Here, an engineer does not draw a part. They simply describe the problem to an AI. They input the parameters, like the size constraints, the forces it must withstand, and the material to be used, and the AI algorithm explores thousands or even millions of possible design permutations. It iteratively learns and evolves the shape to create the most efficient, lightweight, and robust solution possible, often resulting in complex, organic-looking structures that a human designer would never have conceived. This collaboration between human ingenuity and machine intelligence is creating a new generation of hyper-optimized parts. AI is also making the printing process itself smarter and more reliable. Machine learning algorithms can monitor a print in real time, using sensors and cameras to detect potential errors before they become critical failures. The AI can identify issues like warping, layer shifting, or nozzle clogs and automatically adjust the printing parameters, such as temperature or speed, on the fly to correct the problem. This self-correction capability dramatically improves the success rate of complex prints, reduces material waste from failed jobs, and allows printers to operate with less human supervision, paving the way for truly autonomous digital factories of the future. This synergy is also accelerating the discovery of new materials. AI algorithms can analyze vast datasets of chemical properties to predict and simulate new polymer or metal alloy formulations with desirable characteristics such as greater strength, flexibility, or heat resistance. This dramatically speeds up the research and development process, which traditionally relied on slow trial-and-error experimentation. By intelligently guiding material science, AI helps create better inks for our three-dimensional printers, expanding their capabilities even further. The fusion of AI and additive manufacturing is not just an incremental improvement, it is a leap forward, creating a smart, adaptive, and powerful production system for the 21st century. As three-dimensional printing becomes more affordable, will these machines become as commonplace as the personal computer? The prospect of a three-dimensional printer in every home signals a shift towards becoming active creators, empowered to produce objects tailored to our needs. It represents the ultimate democratization of creation, putting the power to make directly into our hands. The ability to create what we need, when we need it, could foster a more mindful and sustainable approach to ownership. The personal manufacturing revolution could unleash a new wave of creativity and practical problem solving. To fully harness the potential of this manufacturing revolution, we must equip the next generation with the skills and mindset to thrive in a digitally fabricated world. The inclusion of three-dimensional printing in our educational curricula, from primary schools to universities, is not just a novelty. It is honestly an absolute necessity. It provides a unique hands-on way to teach core STEM subjects, science, technology, engineering, and mathematics, in a way that is engaging, tangible, and relevant to the real world. When a student can design a solution to a problem on a computer, print it out and hold it in their hands, abstract concepts suddenly become concrete and, well, genuinely exciting. In the classroom, three-dimensional printers transform students from passive recipients of information into active problem solvers. A history class could print replicas of ancient artifacts, allowing students to physically interact with the past. A biology class could print detailed models of cells or organs, making complex structures easier to understand. An engineering class can design, print, and test multiple iterations of a bridge or a catapult, learning directly from both success and failure. This process teaches critical thinking, spatial reasoning, and iterative design, essential skills for any future career in the 21st century, regardless of the field. This educational shift is crucial for bridging the future skills gap. As industries increasingly adopt additive manufacturing, the demand for a workforce with digital literacy and design competencies will soar. We will need skilled technicians who can operate and maintain the machines, materials scientists who can develop the next generation of printing substances, and most importantly, creative designers who can imagine the innovative products of tomorrow. By introducing these technologies early, we spark curiosity and inspire young people to pursue these high-value career paths, ensuring our economy remains competitive and at the forefront of innovation. Integrating three-dimensional printing into education, much like coding and artificial intelligence literacy, is a fundamental investment in our collective future. It cultivates a generation that is not intimidated by technology, but sees it as a powerful tool for creation and change. It prepares young minds for a world where the boundary between the digital and the physical is, increasingly blurred. The students who learn to design and print today will be the architects, engineers, doctors, and entrepreneurs who will build the sustainable, customized, and innovative world of tomorrow. The classroom, therefore, is the true starting point of the three-dimensional printing revolution. The rise of any transformative technology inevitably raises questions about its impact on employment. The integration of three-dimensional printing and automation into manufacturing will undoubtedly change the landscape of work, but this change should be seen not as a threat, but as an evolution. While some traditional repetitive manual labor roles on assembly lines may be displaced, a host of new, more skilled and more engaging job categories will emerge in their place. This technological shift is not about replacing humans, but about elevating their role in the manufacturing process, moving from manual execution to creative design, strategic oversight, and complex problem solving. The workforce of the future will be defined by digital competencies. There will be a massive demand for three-dimensional designers and CAD specialists who can translate ideas into printable digital blueprints. We will need materials engineers to develop and perfect the ever-expanding palette of printable substances. Skilled technicians will be required to install, operate, and maintain fleets of advanced printers. Furthermore, an entire ecosystem of supporting roles will flourish, from software developers creating the next generation of design tools, to supply chain experts who manage digital inventories and localize production networks. This evolution of skills has the potential to create higher value, more fulfilling careers. Instead of performing a single, monotonous task for 8 hours a day, the worker of the future will be a creative collaborator, using technology to solve unique challenges. Their value will lie in their ingenuity, their design flair, and their ability to manage complex automated systems. This shift could also lead to the reshoring or onshoring of manufacturing jobs, bringing them back to countries where they were previously lost. As the competitive advantage moves from cheap manual labor to skilled innovation and automation, local production becomes economically viable once more, strengthening domestic economies. The key to navigating this transition successfully lies in a commitment to lifelong learning and workforce development. Governments, educational institutions, and businesses must collaborate to provide accessible training and reskilling programs, ensuring that people have the opportunity to adapt to the new demands of the job market. The history of technology shows that while it disrupts old jobs, it invariably creates new ones that we can scarcely imagine today. The challenge is not to resist this change, but to embrace it, investing in our people to ensure they are ready to seize the exciting opportunities of this new industrial age. As we look towards the grandest of human ambitions, the exploration and potential settlement of other worlds, three-dimensional printing emerges not just as a useful tool, but as an absolutely essential enabling technology. The sheer cost and difficulty of launching every single tool, spare part and structure from Earth makes long-term sustainable space missions a monumental challenge. Every kilogram launched into space costs thousands of pounds. Additive manufacturing offers a revolutionary solution. Instead of packing everything we think we might need, we can pack a printer and a supply of raw materials and simply manufacture what we need on demand. This capability is fundamental for establishing a human presence on the Moon or Mars. Astronauts could print custom tools for scientific experiments or replacement parts for critical life support systems, a habitat module, or a rover. This dramatically increases mission resilience and self-sufficiency, reducing the reliance on a fragile multi-million-mile-long supply chain back to Earth. If a component breaks, a new one can be printed within hours using a digital file, a capability that could be the difference between mission success and catastrophic failure when help is months or even years away. The ultimate vision for space exploration is to use the resources of other celestial bodies themselves, a concept known as in situ resource utilization. This is where three-dimensional printing's potential becomes truly awe-inspiring. Giant autonomous printers could be sent ahead of human crews to build entire habitats, landing pads, and protective structures using local materials like lunar or Martian regolith, the loose dust and rock on the surface. These printers would mix the regolith with a binding agent to create a concrete-like substance and layer by layer construct the infrastructure needed to support human life, shielding them from radiation and the harsh alien environment. This technology is the key that will unlock our future as a multiplanetary species. It transforms the challenge of space exploration from a purely logistical problem of transport into a manufacturing opportunity. On Earth, three-dimensional printing is revolutionizing our industries and societies. In space, it will be the very tool we use to build new worlds. It represents the pinnacle of localized manufacturing, turning the dust of another planet into the foundations of humanity's future. The journey to the stars, it seems, will not just be launched from Earth, but will be printed layer by layer across the cosmos. We have journeyed from the factory floor to the final frontier, exploring a technology that is fundamentally reshaping our world, layer by delicate layer. Three-dimensional printing, or additive manufacturing, is far more than just a novel way to create objects. It represents a paradigm shift in how we think about production and innovation. It is the dawn of the digital forge, an era where the boundary between a digital idea and a physical reality becomes almost seamless. This technology empowers us to move into a future of mass customization, where products are designed for the individual, enhancing their value in our daily lives. The implications are profound, promising a more sustainable and efficient future by designing waste out of the system. By enabling localized, on-demand production, we collapse fragile global supply chains and build more resilient local economies. This revolution is about people, empowering designers and entrepreneurs with the tools to innovate faster. From printing homes to printing tools on distant planets, three-dimensional printing is a testament to human ingenuity. As the technology becomes faster and integrated with artificial intelligence, the possibilities will only continue to expand. It will be a world where the power to create is more distributed, heralding a future not just of manufactured goods, but of manufactured opportunity for all. The digital forge is lit, and it is forging our future. Nowhere is the transformative potential of three-dimensional printing more profound than in healthcare. The ability to create perfectly customized objects can be a matter of life, death, comfort, and pain. Additive manufacturing is ushering in an era of truly personalized medicine. We are seeing the creation of prosthetic limbs tailored to exact dimensions, dramatically improving quality of life. Surgeons can now print precise, three-dimensional models of a patient's anatomy, allowing them to plan intricate surgical procedures with unprecedented accuracy. Beyond models and prosthetics, we are on the cusp of bioprinting. Scientists are now using modified three-dimensional printers to build living human tissues. Even the humble pill is being reimagined, allowing for the creation of personalized medications. Additive manufacturing is fundamentally rebuilding healthcare from the patient outwards, promising a more effective future for all.